So that was the first part, right? Like the introduction. Now we'll try to dive a bit more into the details of SpeechBrain, and we'll start with a brief toolkit overview. So this means that we will see all the different resources that we provide to the community. So we'll first go through the website, the different tutorials, you can find them, and we'll move through the discourse, that is the place where you want to be if you have any high-level questions. And finally, of course, the code, right? The repository, which is the main point here. So I guess the very first jump we can do is on the website. So nothing much to say about it, right? Like this is the place you can browse if you are looking for information, like general information about SpeechBrain, who we are, what we are doing, what are some key features. I mean, that's a basic website, so not much super exciting here. But you can also find all the different links that will redirect you to the resources we provide, such as the GitHub, the discourse, and the Hugging Face Hub. What is very important about this website is the fact that it's the only place where you will find all our tutorials, right? So you can find them under our tutorials menu, of course, and you can see that they are grouped depending on the level of difficulties, basics, advanced, or tasks, if you are more interested about task-specific tutorials. For instance, if you go to SpeechBrain Basics, you will get all the information about, well, basics of SpeechBrain, right? But this is basically what we will cover today in this tutorial. So maybe if you just want to get refreshed, feel free to jump here and you'll get a great look again at what we will discuss today. But if you are looking for more and more advanced, of course, like advanced stuff, well, you can go to advanced and then, I mean, move to the different topics that you might be interested in, such as speech recognition, source separation, speech enhancement, etc., etc. All the tutorials are hosted in Google Colab, right? So this is quite important for us because it allows basically anyone to use GPUs if needed for the tutorial, because that can be useful, for instance, when we investigate ASR training, like speech recognition, when you want to train your acoustic model and give an example to the community or users how to train it. Well, you kind of need a GPU so it works rather quickly, right? And so in these tutorials, of course, you will find many different information about the specific topic that is working on. We carefully usually design them to be as close as possible as small lectures, right? So you can get all the information, not only linked to SpeechBrain, just like Mirko said earlier, but also linked to the specific field or topic that you are looking at this point in time. So yeah, that's a good place to start if you are interested in SpeechBrain, or if you, I don't know, go over it and get back to it in 3 weeks, just feel free to get back to the website, tutorials menu, and you will get all our tutorials. Of course, we are adding new tutorials every week or month, depending on the features that are coming out. Then you have the discourse, right, that you can directly access through the website, but there it is. And so this is an intermediate place. It's not like super high level, but not as detailed as GitHub, right? Like in GitHub, you might discuss bugs or issues related to the toolkit or things that you are implementing. In Discourse, you might engage with the community, right, with SpeechBrain community. So here, the idea is to, of course, read the README before posting anything. But basically, you can choose within the different categories we have that are either announcement or just specific to the topics that you are interested in. And then you can propose many things, basically. So if you spotted a problem that you would like to discuss, or if you are interested in a new field that is not explored yet with SpeechBrain, you can just post something, and maybe some other people from the community will jump into the discussion, right? This happened, for instance, with someone discussing emotion recognition a while ago, and so many people get involved, and in the end, well, the discussion started to grow, and new features went out of this discussion. So this is the place where you can go to engage really with the community, right, at the high level, discussing about what is next or what you would like to do, and getting help about it. So most of the time, people from the team, right, from the SpeechBrain team will answer you, but we are starting to get more and more people external to us involved, which is the goal of this World Discourse. Then, as mentioned by Mirko, we do put an emphasis on documentation. I mean, most of the toolkit have documentation, right? Like ESP.NET has documentation, Nemo has documentation. And the thing is, we all are hosting it on Read the Doc, if I'm not mistaken. So they look pretty similar. The thing is, on this documentation, we put a lot of effort on it because this is at the heart of SpeechBrain, being as easy as possible to grasp and to start with, and even to be used as a resource for education, right? So of course you will have high-level information on the toolkit, like how to install it, the different possibility of installation that we will see later on, some question regarding your operating systems, the environment, etc., etc. You will have also the basics of running an experiment, just in case you missed the tutorial. So we recall this here again. And then also some basic consideration about GPU, multi-GPU training, information about the tutorials, all something that is quite important that we will discuss later on, but a full page on how to contribute to SpeechBrain, because this is like at the heart of the project, right? Like we need your contribution. We need people to get involved into this so it grows, which is currently the case. That's great. So here you will find all the information, all the things you need to do before or to contribute to SpeechBrain. And of course, it's a documentation. So, well, you will have the API documentation attached to it. So, for instance, if you look to any module here, spec augment, right, you will find information about it here. And as Mirko mentioned earlier, every single class features we provide that is merged to SpeechBrain will have a first header that will point you toward the right resource if it's something that has been implemented from somewhere. Here, for instance, you can find a paper in reference with spec augment. You will have also the full list of parameters updated with the type of parameters, what it corresponds to, and a working example. And so this working example, which is here, is crucial because not only this is very useful for the users to get started with a class or a function, right? Like if you want to check what is the output shape of a function, the best thing you can do is just start your Python interpreter and just run directly this and see what happens, right? What is the shape? What is the input shape, etc., etc. But it is also used for our continuous integration scheme. It means that every time you will push a new code to SpeechBrain, we will run all these examples, and they have to pass, right? Like they have to run, because it means that if they do not run, it means that future users will just run them, try to play with them to understand the function, and of course it won't work, which is just terrible. And so we use it as a continuous integration example. So it means every single example you see here should run. If it doesn't, it's not normal, but for now, it has never happened yet. And this is directly transferred to the code, right? So you can see the source code, thanks to Read the Doc again, and it's just what Mirko said earlier. So you will have for each class this header with some information, the argument again, and the example. So it means that if you're not interested in going into this documentation, so Read the Doc documentation, you can still find it directly in the GitHub because all the headers are documented in this way. Right, so I guess we can jump now to the main part of this section, which is the repository. So, well, nothing really new here, right? It's a GitHub repository. So in the README, you will basically get a summary of all the resources that you might need to get for SpeechBrain. So all the different links to the resources again, the list of key features. So this is great to better understand what are the key features of SpeechBrain compared to other toolkits, for instance. And then you will also have a list of supported tasks and the model we implement, etc., etc. That might maybe be of interest for you depending on the research you are into. You also have a quick summary of the performance, which is not even really up to date because we have 1.9 now on LibreSpeech. But again, if you are interested in performance, I guess the best thing you can do is either browse the recipe or check out our paper where we have the full list of results, because here it's just to, again, just like Mirko said, this is just to see you can achieve state-of-the-art performance with SpeechBrain. Now, using whatever toolkit, if you just do it properly, you will be able to do it. So it's just a matter of seeing that it works. And of course, you will get some information about the documentation again, how to install it very quickly, and test installation, running an experiment. That's again just a bootstrap, right? Like if you are, if you tested SpeechBrain, you went through the tutorials, and then you do a pause of 3 weeks, and then you get back to SpeechBrain, you can jump into the README, and you will get ready again to work with it. What is interesting here maybe is to discuss the structure of the toolkit, right? So you have a bunch of folders that you don't really care about. For instance, docs, tests, and samples are folders that you might not be super interested about, because docs, of course, is all the things related to documentation. So unless you want to contribute to the template of documentation or whatever, I mean, you're free to do it, but that's not the main point of this toolkit. And samples are just audio samples that are used to run the continuous integration tests to make sure that everything works properly. And tests, of course, is everything related to tests. So you might be looking at some point to this folder if you are contributing to the toolkit and pushing quite a big functionality or something that will alter potentially the existing unitary or functional tests, right? But this is like pretty low level, and we are not getting into this right now. Then you have a bunch of folders that are of interest. The first one is recipe, and the second one is SpeechBrain, and the third one is templates. So recipes is just the equivalent of eggs for CalD and ESP.NET, for instance, right? So basically, if you go into recipes, you will get a list of dataset that we support, and then for each dataset, you will have the different tasks. For instance, if we go to voice bank, you will have ASR, CTC, multitask learning, and speech enhancement, right? So it's always the same, just like it was the case for CalD and ESP.NET. So it's like recipe, dataset, task. Then, of course, we have the SpeechBrain folder, which is the core library that we will get back to it in a minute. And then we have templates, which is the place where we store all the templates that Mirko introduced earlier. So basically here, this is the place where you want to start if you are not like ultra familiar with the latest state-of-the-art on speech. And so you don't want to take the latest model that we release under a recipe for a data set and try to apply it to your data. You just want to train from scratch a simple ASR speech recognition system for your own data. You have to go here because you will find a lot of documentation to understand how to run it step by step, how to build it step by step, and comments within the code that will help you to understand what every single block or line of code does, right? So this is the place you want to start with if you are a newcomer and if you just want to do something with your own data. Of course, if you are more familiar with speech in general and you've already been using, I don't know, ESP.NET for years or CalD for years, maybe you can directly jump into recipes and find the latest model that will be obviously more complex than the one that you will find in templates. So the SpeechBrain library. Well, I guess namings are pretty transparent within this core library, right? Like alignment, of course, it's everything related to alignment. Data IO, it's everything that is linked to input and output, and Aku will present this more in details later. Decoders, decoder, LM language model, etc., etc. Maybe some folders are a bit less simple to grasp. The first one is lobes, while the second one is neural nets, right? So lobes is a very special place where we provide functional models. So if you are familiar with PyTorch, basically what we provide here is ready-to-use models that are sequential models. So it means that, look, you want to do some speech recognition, right? So you need an encoder. So you need an encoder that might be a CNN that goes into a recurrent neural network that goes into a deep neural network. So the thing is, SpeechBrain provides all the minimal blocks to do this, right? Like you could just compose a model in PyTorch, which is a convolutional neural network made of n blocks with batch normalization and stuff. I mean, complex model that go into a recurrent neural network, and then that goes into a deep neural network. But this takes quite a lot of time, and it's quite boring to do, right? Like you don't want to do it for every single time you have to design your model. You don't want to always implement everything by yourselves. And so lobes is basically ready-to-use models that does that. For instance, if you go to models, right, and CRDNN, it's exactly what I said. So it's a CNN into a RNN into a DNN, and it's just a sequential model. So as Mirko mentioned earlier, you have the documentation as always that explain you everything and with an example to run it, but it's just a sequential model. You can see it from the code where we happened some CNN block, then we do some time pulling, then we give some information at a weird transformation we do here. And then we have the recurrent neural network here, and finally the DNN neural network. And that's it, right? So lobes are just models that you can use straight away, straight out of the box, that have been used for recipes and that perform usually very well. And that's also why you can find, for instance, X vector here, or even Metrigan, or Hugging Face Wave2Vec2 model, right? Like, it's things that are usually complex to build and that are already given, but they are also super transparent, right? Like, these are only Python code that is well documented, and so you can just jump onto it and modify it if you are interested in playing with some Wave2Vec from Hugging Face, but adding some normalization before the extraction of these features. You could just jump into this, go at the forward function here and modify the forward function just like you would like to do it. And so finally, the neural network folder, which is right here, okay, is the place where you will find all the atomic functionalities of the toolkit related to neural networks. So here you will find everything basically that we provide, that goes from the CNN layer to RNN layers to activation functions to losses to implementation of the different normalization, etc., etc. And every time it's always the same story, I know, but every time it's super documented and really transparent. And if we do things that are not really easy to grasp in the code, usually you will have inline comments, just like it is the case here, for instance, where we explain what we are doing right after it. And so it means that, for instance, you'll see later how to compose this. But if you are using a convolutional neural network and you would like to use the syncon, you can use it straight away like this as a first layer, for instance. But then if you would like to do something specific about it, you can just go to the forward function and modify it, right? Like, do your normalization, or maybe duplicate the class to do it in a more clean way, duplicate the class, modify it with your new functionality, and try it straight away. And it's always the same story. It means when you want to try something, just jump into the code and modify things. It's super straightforward. Right. So I think we are done with the toolkit overview here, and we can already jump into the third part, which is training and inference, because here we got like a guided view of what we offer, right? And I guess now you are a bit eager to see how it works and what we can do with it. So the very first thing is that I have to remind how SpeechBrain works at a very high level when you want to use it, right? Like train a model or just run your own receipt. So the thing is, for all the standard receipt we provide, you will always have only two files, this Python file and this YAML file. So it will always be Python.py file, YAML file, and then the experiment will start. Of course, you can do maybe other things if you want to, right? Like you can customize it so you can do many things with it, but that's the way to do it for standard, I would say, standard SpeechBrain recipe. So Mirko already said some few things about a YAML, and that's why I won't jump into this in details. Aku will, right, to explain you how it works properly and what you can do with it, but I won't do it because it's here pretty natural, right? Using YAML in the end is super natural, and when you did it at least once for your own very first receipt, then you're good to go, right? Like you directly understand how it works, and it's super powerful. The .py file, however, is something a bit more unique for SpeechBrain as a toolkit, right? Like this is something you might not see in other toolkits. So this is why I will spend a few minutes to talk about it here. And of course, Aku will details it block after block later on. So again, in a standardized SpeechBrain recipe, it means that you can do other things, you can do whatever. But for the recipes we provide, all the .py files are made of 3 blocks. The first one is the brain class. So this is the first that you can see on the top left here. And basically the brain class is just the backbone of your receipt. It means that this is where you define all the forward computation, what are the objectives that you are training against, what is maybe the accuracy that you would like to report, how do you feed the different batch. I mean, these are functions that you will have to override, and some of them are not like mandatory. You can maybe only override part of them, such as the compute forward that is mandatory, or the compute objectives. And this is just like a toolbox, right? Like the brain class is a toolbox that will allow you to define what is your receipt. When I say what is your receipt, it's like the atomic component. As I said, forward computation, objective, accuracy, all this information that define in the end your model training, just as an actual brain. Then you have the second block, which is the data I/O block, this is maybe the most scariest part when you look at some receipt, and that's too bad actually, because it's a very nice place to look at. So this is where you implement everything that SpeechBrain needs to understand and know about going from your data to feeding the model, right? So this is where you will basically implement all the information about the tokenizer. For instance, you would like to, from some CSV file that you prepared that Aku will present later on, but some CSV file that is representing your data set, you would like to take the field word or transcript, for instance, and you would like to tokenize it with a specific tokenizer. This is where you will precise all this stuff, just like it is the case with Torch transforms. If you are familiar with it, well, we just kind of extended this to speech, and it might sound scary here, but once you did it for your task, for instance, if you did it for your own speech recognition recipe, usually you can just copy and paste the thing to a new recipe, because it will be the same in between speech recognition from one domain, from one dataset to another one. Maybe few things will change, like the length, I don't know, the features that you would like to apply to the length, or some resampling because some of them are not sampled at the same frequency, all this kind of stuff, right? So it's super simple in the end, and it's super important as well, because this is usually not really accessible to users in other toolkits, for instance, or you have to manage it through different files. Here, it's just exposed plainly in the main recipe. And finally, you have the main, right? The main block, which is, if you look for an equivalent, it's just like the, we'll say for an instance, like the run.sh on Caldi or ESP.NET, right? Like these are the different steps of your receipt. Once you declared everything, how do you combine this to make something work? So as you can see here in the example, we're just parsing the argument, then we will load the hyper parameter file, then we will create some experimental dir, then we call the IO function that we just instantiated earlier, then we instantiate the brain class, then we call the fit function that Aku will present later, which is just train the model, basically, and then you evaluate it, right? So that's just a run.sh file, right? So again, all recipe should follow the structure, and if you are designing you can do whatever you want, as I said, but try to stick with it because it's simpler, basically. Okay, so now, of course, but I don't really care. Okay, so now let's see a bit of use of SpeechBrain. So I won't play the sales here just in case we get any trouble, but the very first step, okay, to use SpeechBrain, of course, is to install it. And here you have two ways of doing it. The very first one is using the clone of the repository. So you can just clone the repository and then keep these two common here. So you will install the requirements that are just a very short list. Basically, we try, as Mirko said, to keep this list pretty short. And then you install the library. And if you have a good file system and like your machine is not too slow, this should take less than a minute to do. And if you don't want to install in this way, you can just pip install SpeechBrain directly. But this is something, there is something important to mention here, is that if you do it in this way, so with PyPy, you will get the latest stable version of SpeechBrain, which is different from the one you will get with doing a clone, because you will by default clone the develop branch of SpeechBrain that contains all the latest functionalities of SpeechBrain. So be careful when manipulating in this way, because you might sometimes have some mismatch. For instance, if you clone the develop branch and then you install with PyPy, you might end up with some mismatch and errors in your code, of course. Once you did this, well, the next step is to prepare your receipt. We won't see this now because Aku will do it in details, but let's imagine that you already have a receipt that is ready, right? So you can just go directly to the training phase. And again, as a reminder here, to train a model, it's super simple and always the same thing. Python train.py and then YAML file. And that's only this. And you can see that this is what we are doing on the next cell here. So basically, we are just going to a templates. So it means that this is something you can actually play with, right? Like this is something we do here for the tutorial, but you can do it directly because it's given in the repository. And then we just call python train.py/train.yaml, and then the training will start. Something that I would like to mention here is related to the overriding functionality here. One very good point is that every single argument or parameter that you put in your YAML file, which is the configuration file, so it can contain, as we briefly saw earlier, but you will see it later, but it can contain complex modules, right? Or simple arguments like the number of epochs that your model will run on. Well, you can modify everything in the command line. Every single thing that you put in your config file can be directly changed through the command line when you start the experiment. And this is great if you are, I don't know, playing with some resource manager, for instance, when you want to have like a 10 job started with different hyperparameters, then you can just do the search, which is like doing search is not great, but you can do it very easily, or basically just modify, for instance, the data folder. If you are playing with different machines or different servers, you can modify everything that is in the YAML with this command line. And so when it starts to train, you will just get a bunch of different logs, right, directly in the output. And so, for instance, you will get the information about where the results or all the logs will be stored. We'll see this a bit later. And then you will get some information here that are quite specific, right? Like we are calling SpeechBrain.pretrain.fetching. So every time you will get some information as well about what is the part of the code that is logging this, of course. And here, what happens is that in this example, in this templates, right, we are giving an example about training some speech recognition, but it is usually quite a heavy task. So we are downloading and loading pre-trained models. So pre-trained model for language model, tokenizer, and ASR, which is the acoustic model in this case, right? And it's also written that it is using the symlink that exists here. And then you just have an information about the parameter transfer package. Let's say we are loading pre-trained files for LM tokenizer and model. So this might looks and sounds a bit hard to get here, but the thing is we provide very easy way to do this. So it means that if you have pre-trained models, usually if you do it properly, you can just transfer them and reuse them for further experiment, like fine-tuning or transfer learning or just ablation studies or whatever. You can do it very, very easily. And then you get some information on the model itself, such as the number of trainable parameters. So the parameters that require grab, right, in the PyTorch, way. So here we have more than 100 millions, close to 200 millions, of course. And then, well, the training will start. So of course we have some resuming functionality here. It's not the case because the training just starts. So it says we'll load a checkpoint here, but none found yet. But if your job got killed at, I don't know, the third epoch, it will restart at the third epoch. And you even have some functionalities that allows you to save your model every n minutes, for instance. If your epoch, for instance, lasts for a week, you don't want to only save a checkpoint at the end of this epoch, of course. So this is why we allow this functionality. And then you have some logging about the experiment itself of the training. So you have some information reported here that you can change directly in the code if you're interested, and the progress about it, the remaining time. This is quite standard, right? And if you don't want to have this progress bar, you can, of course, disable it. So this is for mono GPU training, right? But sometimes you want to throw some compute at your job. And so here, SpeechBrain supports two different multi-GPUs methods. Basically, the two that PyTorch supports as well. The first one is data parallel, and the second one is distributed data parallel. So the difference between these two methods lie in their handling of Python and Python threads in general. So data parallel will spawn one Python thread for all the GPUs, right? So it means that you can get a bottleneck once you increase the number of GPUs that you will be using. So if you have 8 GPUs, you might get a bottleneck because you will only have one Python thread managing all of them. While for distributed data parallel, well, it's not the case because they will spawn one thread per GPU used. And this is quite harder to handle within a toolkit. I guess all the people familiar with DDP know that it's not super straightforward, but it's pretty well implemented in SpeechBrain, and you will get, of course, the same results or very close results if you are using either data parallel or distributed data parallel. And of course, that's my opinion, but if you are going for using more than 2 GPUs, switch to DDP because like you will see potentially something that is close to a linear gain in terms of training speed when you increase the number of example in your batch size, of course. So SpeechBrain supports both of them, right? And as you can see, this will transform for data parallel. This will transform your command line to this. You will just have to add 2 parameters. And then for DDP, you just have to call the torch.distributedLunch script before and inform SpeechBrain as well about the backend that you will use. By default, it's in CCL, but you can change it if it doesn't work on your cluster. Right, so this is for training your models, right? So at this point, it means that you started the training of your model because you have your receipt done, everything went well. Hopefully you don't have any errors, so you will get an output folder. And what will be contained in this output folder depends on the receipt that you run, okay? By default, you will always have one single folder of output where everything will be stored. Of course, you can change it and customize SpeechBrain in the way you want and have many different folders. And by default as well, some files will always be stored to replicate, to facilitate replicability. This is like a really crucial point for us as researcher to facilitate this replicability because like models are getting more complex, right? And so sometimes you just can't achieve the same level of performance. So the best thing that we can do here is to facilitate this by giving as much as information about what was the environment of training at this point in time to achieve these results. And we'll see later what are these files. But the thing is, like most of the files, right, in this output folder are receipt dependent. For instance, if you are doing some speech recognition, maybe you will have a file that will report the water rate on your test or dev or whatever data set that you want to transcribe. Or if you do some speaker ID, maybe you will have some, or speaker recognition, whatever, you will have some equality rate file instead, right? So then it depends, but everything will be stored here. One important point, though, is that we support 3 different loggers, right? So the main one that we use in all the recipe is the text logger, which is the simplest form of the logger. So we'll see it later, but it's just a text file, right? Where we store the training loss, accuracy, validation, all the statistics. But you can also, of course, use TensorBoard and weight and biases as well. So how does it look like? Wait, we can get an example. For instance, if we go to our recipe, common voice, speech recognition, and we'll see later why we have this here, but basically we provide a folder. So that's a save folder. So you will get a folder like this. The 1, 2, 3, 4 is basically just the seed that we use for this experiment. And then we will have like all these different files. So the environmental.log here is a dump of your Python environment at this point in time. So you can, someone can just look at it and try to stick to the exact same version of PyTorch, Torch Vision, whatever functionality or package that you used. Then you will find the YAML and the .py file. So it means that the YAML you use to train this experiment, so in this case, it's this one, right? And the .py, the main, so the actual receipt script are given to the community, right? So you can exactly know what happened, right? And so if you have the SpeechBrain version, the version of the different packages, the YAML, and the training script, you should be able to replicate the results. And if it's not the case, then maybe we can start discussing because it's not normal. So then you have the log.txt, which is just a dump of the full logs that you will get. So it can get pretty noisy if you look at it, right? And this is the logger that I explained earlier. So this contains the logs of the experiment that you are running. So here it's speech recognition, and you can see that for each epoch, right, we have the learning rate of the different model, wave to wave, etc., the loss, validation loss, character rate, water rate, and then at the end, the test water rate obtained, right? So this is completely, you can customize it just like you want, right? So if you want to add something, your specific custom loss or your specific custom accuracy metric, you can do it, right? You can log here any information you want, and I could certainly will present it later. And this is the water rate file, for instance, that is generated for speech recognition. So you will have some statistics about the dataset that has been transcribed. So we achieve a water rate of 15% here, for instance, and then you will get at the top the reference, right, and then the prediction of your model. So here you can see it's 0%. Great, it works, and this is generated for the whole dataset. So you can have a look at what happened, just like in pretty much any other toolkit, I will say, but that's still an important functionality to have. Okay, so the next step then, if we are able to produce such a packaging, I will say that allow reproducibility is to share and reuse pre-trained and trained models, right? And this is a next step that we will see here, is that most of the time for every single receipt we provide, okay, we also give this directory I show you, right, like this one. So if you go to any SpeechBrain receipt, we go through ESR, sequence to sequence, you'll get so in the table of the results, you will get the model link that correspond to all the folders. So you can see what happened, what is the water rate, and you can try to replicate everything. And if you fail at replicating something, please let us know so we can see what happened, and so we can just rectify or do something about it. But as you can see here, there is also something else, right? Hugging Face link. So this is quite special. This Hugging Face link is only available for our best models, but not only models in the end. It means kind of full pipeline. By this, I mean that if we provide something on Hugging Face, it means that you can use it straight away. So if we provide a speech recognizer model on Hugging Face, you can use it directly to infer, just infer on your audio file to get a transcription, right, of this audio file. And this is so the inference and training part here. For SpeechBrain to do this, what we do is to provide interfaces, right? So interfaces are just way of loading pre-trained model that have been trained with SpeechBrain, of course. So it means that any models you train yourself, if you just work on it like 10 minutes and following the tutorial, you can infer on it very simply. So go from the research case to simple production case where you can just use a model and infer directly on the WAV file in a few lines of code, just like Miyako presented earlier. So if you want to have quickly a look at the code here, how it looks like for the interface, it's quite simple. We'll go, it's not here, it's not here. It was here. SpeechBrain, trained, and it's transparent. Again, you will find it in the YAML once you are familiar with using SpeechBrain. But basically, we just provide code for interfaces. So for instance, here it's to do end-to-end spoken language understanding. If you scroll down a bit, you won't find maybe something that is encoder, decoder, ASR, to do ASR, with the documentation and example. So these are, I will let you take a look at it because we won't jump into this, but basically they provide basic functionalities to infer from pre-trained model. And so if we jump to Hugging Face, so this is our Hugging Face hub here, you will find all the different models and recipes, I mean, more like systems that we provide here, so 25 right now. And they usually come with some functionality so you can play with them. For instance, if you go over this one, which is a CRDNN with CTC plus attention, so it's speech recognition on French, common voice French, no language model, you'll get some information on the results. You also get some information about how to install SpeechBrain, how to use it. And as you can see here, again, it's like 3 lines of code only. So you just need to import the corresponding interface. So it's encoder, decoder, ASR that we just saw earlier. Then you will call this function, which is from hparams, that will download and basically instantiate your ASR model with respect to the hparams of this file. Here we call SpeechBrain underscore ASR CRDNN common voice. That corresponds to the, as you can see on the URL here, it's the name of the repository on Hugging Face. But you can change the source with a local folder if it's your own model, right? So if your YAML is correctly formatted, it will be loaded and you can infer on it. And then Well, you just call model.transcribe file. And this function, transcribe file, might change depending on the interface, right? Like it can be do speaker verification or other things. So you have to look at the interface that you are using. So in this case, it's encoder, decoder, ASR, to understand all the function that you can use. Maybe just encode instead of getting the full transcription and this kind of thing. And so on Hugging Face, there's a nice functionality, so you can play with it if you want to have a look at it. So I can try quickly here. Bonjour à tous. Right, and so you have the audio file here, and then you can compute directly the output of this. Usually it's a bit slow, right? So maybe we'll jump into another model so I can show you at the same time. Oh, I'm sorry for that. Sorry for that.
Yeah, it is slow just because, you know, it's downloading the model, not because the inference is slow.
Yes, of course. It's slow because it's downloading and loading the model itself. And then you have, for instance, Italian here. Buongiorno a tutti. I'm sorry for my accent, right? I'm not really good at speaking Italian. So here you have the transcription here, bonjour a tous, which is what I said, basically. Okay, let this one train. That's fine. And so we have for others, right? Like we don't have only speech recognition. You can do the same with speaker verification. And here you have the example, right? It's always the same story. So you have to import the corresponding interface. So here it's encoder classifier, and then you will load the model. So here it's the speaker recognition eCappa model. And then you will load an audio file for the example. You will encode the batch. So this is a functionality only given to the encoder classifier interface. And then you get the embedding. So this is kind of like a speaker embedding, right? Like the old, not old school X vector, don't say old school. It's like the eCappa embedding that you will get here, and you can see the shape. And then you can also directly perform speaker verification, okay, straight away. So unfortunately, I cannot do it here because the audio won't go through the share, the screen share, so you won't hear what I will hear. So there's no point in doing this. But this is just another example, right? So if you import the speaker recognition interface, you can load the model and then call directly verify files with a first example, a second example, and then, well, you will just get the answer here, which is false, which means these two speakers are different, right? With the predicted score just above. And I mean, you can't hear, but I can tell you that this is true because they are not the same speaker. And the exact same thing goes for source separation. Same problem, you won't be able to hear the example, but it's the same story, right? You look at the interface that you are interested in. Here it's former separation. You load the hparam, you call this to the Hugging Face hub or your local model, and then you just call separate file with a mixture of audio, and then you will get a list, right, of different extracted, separated audio files. And there is also an example on spoken language understanding, but that's it. That's it on my part. So I don't really know where we are. Let me stop sharing the screen first so we don't have this weird effect.
Thank you very much, Titouan.
Yeah.
So yeah, it's a shame you cannot play signals because, for instance, I think that the speech separation one are pretty impressive. But anyway, you can find these tutorials right in the website. So you probably you can play with that, right? So there is one tutorial called "What I Can Do with SpeechBrain" that contains that, so you can play with that.
I guess one thing we could do here maybe is to take, because it was planned like this, but maybe we can do like a short break, right? Like
yeah. So what about if we do? Maybe it looks like we are 5 minutes late. But what about if you do a small break here,
like maybe
and
10
meanwhile,
minutes?
maybe 10 minutes, and maybe meanwhile we reply some of the questions that are there. I know. So there are some questions I have to figure out how I can activate them. I think we should just put invite, but let's do that. So let's do 10 minutes break. We start in 10 minutes, And meanwhile, we stay here to reply your question if you have one.